Hello everyone, I am Manhar Sharma. Today we will learn about center of mass and center of gravity. So what is the center of mass? The point at which the mass of the body is concentrated. Here the formula will be m1x1 up to mmxn divided by m. So here m will be mass and x will be position of the particle. And this side, center of gravity, the point at which the weight of the body is concentrated is called the center of gravity. So Cg will be W and dn divided by total weight. So W equals to weight and d equals to distance from axis. Here, center of mass, it will be in field. Suppose I have a particle. So its center will be around this point. It will be in 3D, and in center of gravity, if I have random particles, then the center will be this. So it's the center of gravity and it's the center of mass. Okay, so now let's perform an experiment on center of mass and center of gravity.
To find the center of mass of a regularly shaped object like this block of wood is nice and rectangular, uniform density, same thickness throughout the center of mass. I can just take my ruler, I can draw diagonal from one corner to the other corner and draw another diagonal on the other corner. Then where the two lines intersect, that's going to be my center of gravity of the object. What I will do, I will just take a nail and I will insert it into the center of gravity. Now I am going to take this string that has a weight on it. This is called a plumb bob. Anything I hang it from this, it will straight down because of gravity, and that will show me the direction of down, and now I can see the point about which the center of gravity is directly over. Center of mass in an irregularly shaped block. You will see I have cut a corner out of this, so it's no longer a nicely shaped rectangle. What I have done, I have hammered a nail into it so that I can support the block by nail. I know that the center of mass will always hang below the point of support. When release, it swing so that the center of mass is always below the point of support. From second point nail string intersection, I will get a center of mass. So now you can see when I insert a nail at intersection point, it really rotates nicely at the center of point, even though this was a very irregularly shaped object since I know the center of gravity. Now the same thing I did it with wooden plate and got center of gravity point from intersection. Now same concept method we can use it in a triangular metal plate and can get a perfect central point. As you are seeing, I am getting a point from three different corners of triangle and getting a perfect center of gravity point. Now you can see in a combination of irregular mass distributed but perfect rectangular shaped plate. Center point of same material will be half at width and half at breadth, but it's a combination of a metal and wooden, so it will be different. Definitely the center of gravity point will be go to side the metal plate because it has a heavy weight compared to wooden. I am getting this point through our previous plumb bob method. If my center of gravity point will be right, then it will balance on my one finger. Even if this rectangular made from different material and it's perfectly balanced.